Today we're going to talk about multi-step dimensional analysis, and just like its name suggests, we're going to need more conversion factors than just one. We're not going to be able to do these kinds of problems in just one step because we're not going to be able to find, for instance, in this first one, an example of a conversion factor that goes from kilograms to ounces. Now, granted, you might be able to find one if you Googled it or something, but if you look at our conversion factor page over here, there's not a conversion factor that goes straight from kilograms to ounces. So what we're going to do is to figure out a pathway for how to get from kilograms to ounces. And we think about the things that we do have conversion factors for. We know that if we have 1 kilogram, we have 1,000 grams. So we know that's one conversion factor that we can use. We also, if we look back on that conversion factor page, we can find a conversion factor that says that if we have 1 ounce, that is equal to 28.346 grams. So we have a kilogram to gram conversion factor, and then we have a gram to ounce conversion factor. So we have a way using these two conversion factors to get from kilograms to ounces. So let's show how that would look in the problem. We're going to do it just like we've done before. We always start with what we know. So we're going to start with the 0.0250 kilograms. We're going to put that over 1 in parentheses. Remember, whatever we underline up here, piece of information that we're given is always what we put over 1 in parentheses in our calculation. So we may not know anything about our next conversion factor, but we do know one thing. In order for our units to cancel or reduce to 1, we're going to need to have kilograms on the bottom. So if that's true, we look up here for our conversion factor, and the one that has kilograms in it is this one. And since we want kilograms on bottom, the 1 kilogram is going to go on bottom. The 1,000 grams is going to go on top. Now, there are multiple ways to do this problem. So, you could find different conversion factors that would give you a different pathway, which is why I'm not going to require you to show your conversion factors in brackets, because they could be different. The way you set it up could be different, but the form must be the same. You must show me these conversion factor brackets, start with what you know, have your answer as a USS, unit sig fig scientific notation answer. So kilograms will cancel here. Right now we're left with grams. Is grams what we are looking for? No, we're looking for ounces. So we know we're not done. So since we're not done, we know we need another conversion factor skeleton. So we've got the conversion factor skeleton, and we may not know what we need where in the next conversion factor, but we always know that whatever unit we're left with over here in our calculation is what we must put on the bottom in our next conversion factor skeleton so that they will cancel. So far we've canceled kilograms. We are now going to cancel grams. And since we're looking at grams, we know that this is a conversion factor we need. And since we want grams on the bottom, we know the 28.346 is going to go on the bottom, and the 1 ounce is going to go on top. Now that we've done the cancellation, we have ounces left on top. Is that what we're looking for? Yes, it is. Now, so far, of the things that I have written down, this part that I'm going to block in green up here is the part that you do not have to have on your worksheet. You don't have to show me those conversion factor equivalence statements. But everything outside of that green box, all of the rest of this must be there. You don't have to have this interim value. When I plug this in my calculator, remember we always multiply by what's on top, divide by what's on bottom. So we can kind of do this in a crisscross fashion. I'm going to say it using the ones right now, but we know when we multiply and divide by ones, we're really not changing anything. So I always leave those out. But just to complete that zigzag, if you will, we're going to start with our 0.0250. We're going to divide by 1, multiply by 1,000, divide by 1, multiply by 1, divide by 1,000, excuse me, divide by 28.346. We always multiply by anything that's on top, divide by anything that's on bottom. Now, I will admit that I don't mess with the ones. So what I would actually put in my calculator is this. Since these are side by side, I'm going to multiply them. Since this term right here is on the bottom, I'm going to divide by that. So I would plug in my calculator 0.0250 times 1,000 divided by my 28.346. And when I do, I get 0.88196. So if you'll remember from our discussion before, we want this to be in USS, units, sig figs, and scientific notation. So scientific notation first. We're going to move the decimal where we need it to be. We need the decimal to be in between these two 8s, so there's only one non-zero number to the left of the decimal. Since this was a number less than 1, it's going to be times 10 to the negative something. So 8.8196. Since I moved this one decimal place, it's going to be times 10 to the negative 1. So that's my number in scientific notation. Now I need to get it in correct sig figs. If I look at the values in the problem, this value right here has 3 sig figs. The first 2 zeros, those leading zeros are never significant. The 2 and the 5 are automatically significant. That 0 on the end is significant because there's a decimal showing. So 3 sig figs there. 1,000. 1,000 is a counting number, an exact number. It has infinite sig figs. If it has infinite sig figs, it is never going to count in our sig fig calculation. That's like saying 1,000.000 infinity zeros because it's an exact number. So it's never going to count for sig figs. If you remember our kind of shortcut rule for this bottom one, since it has a decimal value in it, it's probably a rounded number, which it is. So this is not infinite sig figs. This one actually has 1, 2, 3, 4, 5 sig figs. And since we always go with the least number of sig figs, we're going to go with 3 sig figs. So going to our answer, I'm going to draw my sig fig line after the 1. Because for my 3 sig figs, since the very next number is a 9, that means I need to round up. So 8.82, drop everything else, scientific notation, I don't have to worry about place value. So 8.82 times 10 to the negative first, we need to make sure we have our units then on the end for our final part of USS, units, sig figs, scientific notation. Ounce abbreviated is OZ, so that's what I'm going to put. And my answer is 8.82 times 10 to the negative first ounces. Anything, remember, in this bottom section that's green, I do not have to, or black, I do not have to have on my on your worksheets. You do not have to have on your worksheets, but everything that's blue or red must be there. Okay, let's do the last example real quick. On this last example, it says how many furlongs are in 5.00 times 10 to the third mils. A mil is actually a unit of length, and a furlong is actually a unit of length. We are looking at trying to find furlongs given mils. There is no conversion factor on our page, on our list of conversion factors, going directly from mils to furlongs. So I need a pathway. So what do I know? Okay, I know that a mil, if I look up mil, a mil is 0.001 exactly inches. That's 1 mil. Okay, what do I know about inches? Okay, well, I don't know where I need to go. Do I need to go to meters? What do I need to do with inches? So I'm going to leave that and see what a furlong is. And I look up furlongs and I see that a furlong is 660 feet. Okay, that gives me a really good idea of what other connecting value I need. Because if I've got furlongs and feet and mils and inches, it looks like I need a connection between feet and inches. And everybody should be familiar with the fact that there are 12 inches in 1 foot. Okay, so those are my conversion factors. And those are the ones that I'm going to need for this problem. So let's start the problem like we always do. We know there are 5.00 times 10 to the third mils. That's what we underlined. We know that has to go over 1 in parentheses. Whatever we underlined in the problem must go over 1 and in parentheses to start the problem. So I may not know anything else about this, but I know I need a conversion factor, so I'll write the skeleton, and I know mils has to go on the bottom. So I'll look up to my conversion factors and I see if I find one with mils in it. And sure enough, I have one up here. That 1 mil is equal to 0.001 inches. And I need the 1 mil to be on bottom, so evidently the 0.001 inches is going to go on top. That's going to cancel out mils. I'm left with inches. Is that where I want to be? No, it's not. I've got furlongs circled up here, so I must keep going. So I need another conversion factor. I'm not done yet, so I need another skeleton. And I need something that has inches in it that I haven't used yet. So I look up there and I see that I have this conversion factor. I haven't used it yet, and it has inches in it. So I know I need inches on the bottom so that my inches will cancel or reduce to 1. So it looks like the conversion factor I need has the 12 inches on bottom, so the 1 foot must be on top. So am I done yet? No, not done yet because I have feet left, but I'm looking for furlongs, so I'm not done yet. So I know I need another conversion factor. So I put another skeleton up here, and once again, I may not know what I need and where I need it, but I know that feet has to go on the bottom so that it will cancel or reduce to 1. The only conversion factor I haven't used is this one right here. The 1 furlong equals 660 feet. So it looks like the 660 has to go with feet on the bottom, so 1 furlong on top. When I plug this in my calculator, remember, I'm not going to deal with the ones. I'm going to look at this. If the numbers side by side, I'm going to multiply. If the next number's on the bottom, I'm going to divide. And once again, if the next number's on the bottom, like the 660 is, I'm going to divide again. So what do I need to do? Really should have put those in green because I'm not going to require you to put those on your paper. So what am I going to do? I am going to take 5.00 times 10 to the third times 0.001 divided by 112 divided by 660. And when I do, I get 0.000633131. So obviously that's not the answer that I have to box because it's not USS. I'm going to get unit sig fig scientific notation. So scientific notation first. I need to move the decimal in between the 6 and the 3 to get it where I need it to be. And since this is a number less than 1, I know that I'm going to need times 10 to the negative something. So 6.3131, I moved the decimal to get it to the correct position 4 places, so times 10 to the negative 4. And now I need to have the sig figs. So I look for the sig figs, and the first number always counts for sig figs. Looks like in the first number I have 1, 2, 3 sig figs. It's in scientific notation, so all those digits are always significant. In the next one, this next value, I told you this was exactly 0.001 inches, which means it has an infinity number of zeros after it. Infinite sig figs, which means it is not going to count towards my sig figs for this problem. 12 is exactly 12 inches. Infinity, 12.000000. It is not going to count for sig figs. 660, exactly 660. It's a counting number. It is not going to count for sig figs because it has an infinite number of zeros after it, an infinite number of sig figs. So the only number that counts for sig figs is this first one, 3 sig figs. So I draw my line, my sig fig line. The very next number is a 3, so I do not round up. I just drop the rest of them. So my answer for this problem is going to be 6.31 times 10 to the negative 4th. Now please don't box that without putting a unit on it. Look up here. Make sure we circled that final unit and that you put that on the end of your problem. So 6.31 times 10 to the negative 4th furlongs is your answer.